These are the solving absolute value inequality notes. There are two types of absolute value inequalities. Greater than, which are going to be your or statements, and less than, which are going to be your and statements. Remember, with or, they usually look like arrows pointing away from each other, and with and, they usually look like the arrows pointing towards each other. All an absolute value inequality does is talk about the distance away from 0. So when working with these inequalities, you have two methods depending on whether it is a less than statement or a greater than statement that you use to solve the equations. With the less than, you're going to set up an and inequality. So this will basically tell you that in the end, when you graph, you should probably have a graph that's going to be pointing towards each other, which also means you're going to have notation that looks like an interval. Okay? So whenever you solve it, the less than, you're going to take your inequality and break it apart into two pieces, kind of like we did with compound inequalities and kind of like we did with absolute value equations. You're going to have 1 minus 2x is less than 9, so the original one that you see here without the bars, and then you're going to have the 1 minus 2x, and like with the absolute value equations, you're going to have a negative 9. But when you flip the sign, you have to flip the inequality the other direction. Okay? Then you're going to solve these both separately and get two different answers, like we did with compound inequalities and with absolute value equations. Okay, so in blue here, you would solve this by subtracting 1 from both sides. You would get a negative 2x is less than 8. Divide by negative 2. When you divide by a negative, you will flip the inequality to the right. So you will have x is greater than negative 4. Over here in red, you would subtract 1 from both sides. Get negative 2x is greater than negative 10. And then turn around and divide by negative 2. When you divide by a negative, it will flip your inequality to a less than. And then negative 10 divided by negative 2 is positive 5. Okay, so if you were to graph this on the number line, your negative 4 would be over here. It would be an open circle, and that arrow would be pointing to the right. For your 5 would be graphed over here. It would be an open circle, and this would be pointing to the left. So, as promised, this was an and, so the arrows are pointing towards each other, so your notation would be open circle gets a parenthesis for your negative 4, and the 5 is also an open circle, so it would also get a parenthesis. Okay, so we are combining compound inequalities and absolute value equations basically into the same skill. Alright, then you'll have a greater than inequality, and these are going to be your ors. So when you go to solve these, the arrows will probably be pointing away from each other, and your notation will look like some kind of parentheses and brackets, the or, and either parentheses or brackets using the negative infinity and positive infinity symbols. Okay, so before you even start the equation or the inequality, you pretty much know what the answers are going to look like. Okay, so since this is an or, you're going to break it apart the same way. You're going to have a 1 minus 2x is greater than 9, so basically the original, and then you're going to have 1 minus 2x, and you're going to switch it to negative 9, and when you switch it, you switch the sign, you switch the inequality the other direction. And then you solve these separately, graph them on the same number line. Okay, so we'll subtract 1 here and get negative 2x is greater than 8. Divide by negative 2 and get x is less than. We have to switch the inequality the other direction because we divided by a negative. We'll get negative 4. Okay, over here in red, we'll still subtract 1 first. We'll get a negative 2x is less than negative 10, and then divide by negative 2. Again, we're dividing by a negative, so we're going to flip our inequality the other direction and get a positive 5. Okay, so when we go to graph this on the number line, we still got negative 4 and 5. Negative 4 is over here with an open circle, but this time it's pointing to the left. 5 would be over here with an open circle, and this time it's pointing to the right. So this does look like an OR. The arrows are pointing away from each other. So when we do notation, it would be negative infinity to negative 4, open circles get parentheses, or 5 to infinity, and open circles get parentheses. Okay, so again, very similar to absolute value equations and very similar to compound inequalities. Alright, why do you flip the sign when you make the number negative? So we make one positive and one negative for the absolute value. Okay, it says all an absolute value inequality does is talk about the distance away from 0 on the number line. So that means you have the positive distance and the negative distance. Okay. But when you multiply or divide by a negative number with inequalities, it flips the sign. So you end up with, for example, if you had a greater than positive 9, when you flip it, when you flip the negative, when you divide or multiply by a negative, you would flip the sign. It will flip the inequality as well. Okay, so you still do one positive, one negative, but you have to remember to flip the inequality. Alright, so example 1. Okay, so in this case there's really nothing to solve here, but we have, in order to drop our absolute value bars, we would have x is greater than 5, would be our distance in the positive direction, and then we would have a negative 5 for the negative distance. But when you flip the sign, you have to flip this inequality the other direction. Okay? If I was going to graph this on the number line, at negative 5, I would have an open circle to the left. On the positive 5, I would have an open circle to the right. This is an OR statement, and it should be, because the inequality was a greater than inequality. So it is OR, and that's correct. And your notation would be from negative infinity to negative 5, parentheses for open circles, and then from 5 to infinity, open circles get parentheses. Alright, number 2, okay, this is a less than statement, less than or equal to, so when you go back and look at the previous notes, less than is going to give us an and, so we should know what this is going to look like. Okay, so you'll have 2x plus 5 is less than or equal to 9, and then I'll rewrite that with 2x plus 5 and a negative 9. When I switch that 9 to a negative, I flip the inequality as well. Alright, so then when I solve in blue here, I'm going to subtract 5 from both sides. Get 2x is less than or equal to 4. Okay, and then divide by 2. I'll get x is less than or equal to 2. In red, same steps, we'll subtract 5 and get 2x is greater than or equal to negative 14, and then divide by 2. So x will be greater than or equal to negative 7. Okay, I did not flip this inequality again because I did not divide by a negative. Okay, so it stayed a greater than. On the number line, at negative 7 would be over here, so in red, that would be a closed circle, and it would be to the right. Okay, in blue, the 2 would be over here. That would also be a closed circle, and that arrow would be pointing to the left. This was an and statement, so the graph looks like an and, so that's probably right. And then our notation, we'd have from negative 7 to 2, and that's it. Just that chunk is the answer. And closed circles get brackets. All right, example 3. Okay, this is a less than statement, so this will also be an and. Okay, so the arrow should end up pointing towards each other. We would have a 5 minus x is less than 12, and then I would rewrite that as 5 minus x with a negative 12. When I flip to a negative, I have to flip my inequality the other direction. So in blue, I would subtract 5, leaving me with a negative x is less than 7. Okay, and then I have to divide by a negative to get rid of that negative sign. Okay, so when you divide by a negative, I'm going to flip the inequality the other direction. All right, in red, I would also subtract 5, leaving me with a negative x is greater than negative 17. And then, again, divide by negative 1 to get rid of that negative sign. When you divide by a negative, I'm going to flip the inequality, so now it's a less than positive 17. All right, on the number line, negative 7 in blue would be over here with an open circle, arrow pointing to the right. In red, I'd have 17 over here with an open circle pointing to the left. With an and, this middle chunk here is the answer, the overlapping section. So I should have negative 7 to 17 is my notation, and then open circles get parentheses instead of brackets. So that would be your notation. Alright, this is a greater than, so a greater than should be an or statement. So when we graph, it should end up looking like an or. So you would have 6x minus 3 is greater than or equal to 9. And then 6x minus 3 is less than or equal to negative 9. When I flip it to a negative, I have to flip the inequality. So in blue, I'm going to add 3 to both sides, and I'll have 6. So our notation would be from negative infinity to negative 1, closed circles get brackets, or 2, closed circles get brackets, to positive infinity. Alright, last example. Like when we did absolute values before, you need to get the absolute value bars by themselves first. So I want to go ahead and add this 10. And I'll have the absolute value of x is greater than 15. And then I'll break it apart into two separate inequalities. So I would have x is greater than 15 and x is less than negative 15. So you got to isolate the absolute value first and then break it apart into two inequalities, just like we did last week. Okay, this is all the solving there is to do, so I can go ahead and graph it on the number line. Negative 15 would be over here with an open circle to the left. 15 would be over here with an open circle to the right. This was a greater than statement, so it was supposed to be an or, which it is, so that's good. So your notation would be negative infinity to negative 15, open circles get parentheses, or 15 to positive infinity.